And there's a quick announcement to make. If you haven't seen the announcement on OnQ yet, assignment 2 came out last night, the night before. I don't remember when now. Anyway, assignment 2 is available. I think it came out 2 days ago on Sunday night. So assignment 2, you're working with strings, lists, sets, and maybe maps if you decide to answer the question that way. So it's due a bit, well, it's due in a week, I think. It's due a week today. Either a week today or on Wednesday. I don't remember when now. I don't remember exactly when. But you also have a midterm next week. So for the next assignment, I want to give you the answers once the assignment is due. So for the next assignment, there is no late assignments will be accepted. Now, if you run into a problem, some sort of medical condition or something like that, you should contact me, and I'll have to we'll have to come up with some arrangement so that you don't get penalized for not being able to complete assignment 2. Because obviously I can't accept assignments after I post a solution. The solutions for assignment 1 will be posted later today. So I think everybody who wants to submit has submitted already. All right, and that's it for the announcements. Now for the lecture, I think we were finishing up the map and collections lecture. Sorry. So let me just quickly review what we were doing in the last class. We were talking about maps. Maps are a collection where you access elements or values using a key, and the keys are unique, so they form a set. You can ask a map for its keys using the keyset method. So this is one of the methods that you use when you want to iterate over elements of a set. So you can iterate over the elements of the keyset, like so. So you call the keyset method on a map called count. And that gives you the set of keys. Now, the interesting thing about the method is it doesn't tell you what kind of set you get back. So if you actually look at the documentation for the method, let's see if I can find a web browser somewhere. This one. So if you look at the documentation for the method keyset in map, you'll see that the documentation doesn't tell you what kind of set you get back. Sorry, it's a little too big. Okay, so there's the keyset method, and it says it returns a set. So it doesn't say if it returns a tree set. It doesn't say if it returns a hash set. It doesn't say at all what kind of set it returns. And we haven't actually seen something like that yet in the course, right? We've seen tree sets, you've seen hash sets, we've seen a linked hash set, but we haven't seen something called a plain old set. So keep that in mind. We'll talk about that shortly. But you can treat the set. So I can keys you treat as a set. So you use any of the methods that we've talked about so far that aren't specific to a particular kind of set. So for example, you can use get. Right, so I can, count. So for example, you can loop over the keys, the set of keys using a for each loop. Right, so for each string k in the set keys, I can ask the map. Right now, I'm using the map to get the value associated with the key. Right, and then you can print out the number of times that the key appears in the set. All right, you can count the number of times. In this example, we're counting the number of times words appear in a list. So in this case, the map keeps track of the unique words in the list, and it keeps track of the number of times each word appears. So when you get the value from the map, that's the number of times that the word K has appeared in the original list. The values in the map are stored. You can also retrieve the values in a map. Right? So there's the keys, there's the values, and you can also get the set of key value pairs. But for the values, now remember the values, they're not unique. right? They're not necessarily unique. And you actually don't know how the map is storing its values. Right? You know how it stores the keys, but the map classes don't tell you how they store the values at all. So how does the map provide you its values? Well, it provides them as a collection of values. We haven't seen collection before yet either, but again, we'll see that shortly. So it turns out a collection is, sorry, let me reverse that a bit. It turns out that things like sets and lists, those are all examples of collections. So this thing values is just a plain old collection. So what can you do with a collection? Well, you can get something out of a collection. You can add something to a collection. And you can loop over a collection using a for each loop. Right? So if you want to calculate the average number of times a word the average number of times any word appears in the original list, right? We can get the values from the map, sum them up, right? Using just using a loop, and then divide by the size of the map. Right now here, I'm using the keyset method. I'm using keyset, and I'm asking for the size of the keyset. But you could also ask for the size of vowels, and you can also ask for the size of count. So those will all give you the same result. Right? Those all tell you how many key value pairs are in the map. Okay, so keyset and values. They don't specify. Keyset doesn't tell you what kind of set it returns. Values doesn't tell you what type. So values doesn't tell you what collection type is returned. Right? Instead, the keyset method tells you it returns a plain old set, and values tells you it returns a plain old collection. And in fact, these two things here, they're reference types, but they're not classes. So there are things called interfaces in Java. So this is the first time that we're now going to look at what an interface is in the course. Now, an interface in Java, in its most common form, is simply a set of methods. But it's a set of methods that are not implemented. So what you get is a bunch of methods and their documentation or their contracts. But you don't get an implementation of those methods. So in other words, it's a specification of an API, right? An interface will tell you what methods exist. It tells you what the methods promise to do, but it doesn't define how the methods are implemented. So in other words, the list interface, or for an example, the list interface tells you what methods every list must provide. Right? So it says, for example, a list must have a get method, it must have a set method, it must have a contains method. But it doesn't say how that method is implemented. Now, the array list or linked list, right? Those are all examples of lists. So when they have, they have to provide every method that's in the list interface. And so that's what it means when a class says that it implements an interface. So let's look at the array list class, for example, or actually let's look at one of the map classes. So let's look at hash map, for example. So if we look at the documentation for hash map, right, we see that under the section all implemented interfaces, it says that it implements the map interface. And so what that means is if you look at the map interface lists a bunch of methods, right? There's a description or a contract of what the method is supposed to do. But none of these methods are actually implemented in the map interface. When hash map says that it will implement the map interface, hash map is saying it will provide an implementation of all the methods that were in the map interface. Right? So one of the methods in the map interface, for example, is clear. Right? So hash map provides a clear method that removes all the elements from the map. Map also says that there's a contains key method. So hash map provides an implementation of the contains key method. oops, sorry. Array list says it implements the list interface. So array list provides implementations of all the methods in the list interface. So things like get, contains, equals. Array list provides a method, a different implementation, an implementation for all of those methods. Interfaces are actually types in Java. So they're considered to be reference types. They're not classes, but they're still considered to be reference types. And what that means is that you can use an interface as a type name. Oh, question about, oh, there's a question about the assignment. Vincent, let me answer that at the end of the lecture, okay? So interfaces are reference types, and that means you can make a variable or you can use create a parameter in a method whose type is an interface. So for example, I can make a new array list. Right? So that makes an array list object. It returns a reference to that object. I can store that reference in a variable of type list. So in other words, I don't have to write array list on this side. I can write list. Similarly, I can make a hash map object. Right now, new returns a reference to that created object. I can store that reference in a variable whose type is map. Right. So I don't have to use the exact type that's on the right-hand side here. If I want to, I can use the name of the interface type here and the name of the interface type here. Now you might ask, now why would I want to do this, right? So why, if I'm making an array list, right, why don't I just store that in an array list object? So the answer is because later on, so when you start programming or when you start to program a solution to a problem, you can, if you choose to use an array list, and then later on you realize that in fact you want a linked list instead, because the problem you're trying to solve would be more efficient or easier to solve if you used a linked list. Then all you have to do is change the new array list on the right-hand side to new linked list, and then everywhere else you use T, you don't have to change any other code, right? As long as you stick to list methods. Right. Similarly, if you make a hash map and then later on you decide, oh, this would have been a lot easier if this map was sorted, if the keys were sorted in this map, right? Then instead of changing this to, instead of changing both sides, right, you can just change this to tree map, and then you don't have to change the type of count in this case. Right. It also gives you other advantages that you'll see later on in the course. Right, so for example, I guess I can describe one of the advantages now. You can write a method that takes in any type of map, right? Instead of writing a method that only takes in tree maps, right? Or instead of writing a method that only takes in hash maps, right? If you create a method that can take in any kind of map, that gives the caller of the method a lot more flexibility in how they use your method. So that's actually the main advantage in this case. Okay. Now, where did all these things come? So where did all of these collections come from? So collection, list, set, map, right? All of these interfaces are defined in what's called the Java collection framework. So I think it was in version 5 of the language when this framework, when the collection framework came out. So it came out when the generics were added to the language. So the collection framework is made up of a bunch of interfaces, classes, and methods. And we've already seen examples of all of them now, right? So for the classes, we've seen things like array list and linked list and tree set and hash map and things like that. So all of those classes, those implement interfaces like set, list, and map. The interfaces in the collection framework, those define what methods the various types of collections support. Right, so the interfaces say what every set must, what methods every set must have, what methods every list must have, what methods every map must have. The classes are responsible for implementing those interfaces. And you've already seen examples of why there are different classes for each interface. Right? In other words, why there are multiple classes for each interface. right? So you know that a hash set is faster than a tree set, right? But there's no ordering on the elements in a hash set, right? Whereas a tree set has a particular ordering of its elements, right? So different classes can implement the interfaces in different ways to provide different advantages and trade-offs, right? Linked list, array list is generally much faster than a linked list, unless you happen to be doing a bunch of inserts and deletes at the front of the list, right? In which case, linked list becomes much faster than array list, right? So again, you have two different types of lists, right? Two different classes, but they implement the same interface. We've also seen the class called collections with an S on the end, right? The plural collections. And we saw in that class, there were a bunch of methods that operated on lists and sets. So there are, the collection framework also provides utility classes that give you methods that operate on collections, right? So you can sort a collection or reverse a collection, sort a list, reverse a list, and things like that, right? All the many utility methods are provided as well. All right, so this is the first time we've seen one of these. So this picture here is an example of a UML class diagram. So UML is short for Unified Modeling Language. So it's a visual language that's used to describe the structure of an object-oriented program. So it's commonly used by software engineers to draw pictures of the architecture of their programs. It's also capable of more than that, of more than just showing the structure of a program. But for our purposes, we're only going to look at structure using UML class diagrams. So in a class diagram, you've got these boxes. Each box represents some kind of type. So for example, this box here represents the interface called collection. And then you can show the relationship of this type with other types. So this is showing you the relationship between all of the major interfaces in the collection framework. So you can see here there's this set interface, right? There's the list interface, and there's something called the queue interface that we haven't talked about yet. We're only going to talk about sets and lists for the time being, right? And down here you can see the sorted set interface. Right? So you can see that the list interface is connected to the collection interface by this line and by this open arrow. So what that's saying is that list, the interface list, is a sub-interface of collection. You go in the direction of the arrow, right? So list is a sub-interface of collection. And all that means is that list, every method that's in the collection interface is also in the list interface. Furthermore, the list interface is allowed to add extra methods. Set is also connected to the collection interface. So every method in every method in collection is also in set. Now sorted set is connected to the set interface. So sorted set is a sub-interface of set. And that means every method in the sorted set, every method in set is also a method of sorted set. Which also means that every method in collection is also in sorted set. And furthermore, sorted set can add its own methods as well. Sorted set, that's the interface that tree set implements. So you can see that there's a difference between a sorted set and a plain old set. Right? So hash set implements the set interface. Sorted set implements the tree set interface, and so you can kind of guess that tree sets can do a lot more things than a hash set can do, and that's actually true. Right? So for example, in a tree set, you can get the first element of the set or the last element of the set, or a range of elements in the set, right? Because the set's sorted. Collection is the so in this what this picture is trying to show you is that collection is the most general interface in this hierarchy. Right? So collection is the interface that says methods like get or contains get, add, contains. Those are the methods. Those are the methods that every collection must provide. Right, which is why list has a method called get, add, and contains, and why set has a method called get, add, and contains. So it's the most general collection. List adds methods that are specific to lists. Set doesn't add any extra methods that aren't defined in collection. But sorted set does add a bunch of methods that are not defined in collection. Okay, so I guess this is going to summarize what I just said, right? So everything that's connected to collection by an arrow, those interfaces are called the sub-interfaces of collection. And all that means is that those interfaces have every method that are in collection, right? Sorted set's connected to set via an arrow. So sorted set has every method that's in the set interface. Now, you might ask where the maps are. So the maps are their own separate interface, right? And that's because for a map, you need a key, and whenever you do something with an element in the map, you're doing something with a key and possibly a value, right? Whereas in these, right, whereas in sets and lists, you're only ever dealing with an index or an element or a value, right? But to put something into a map, you need to specify both the key and the value. So there's really no common, there's no set of common methods between map and collection. So map defines its own separate interface. Now, you also have sorted maps, so like things like tree maps. So there's also a sorted map interface. That's a sub interface of map. You can do extra things with a tree map that you can't do with a hash map, for example. Right, again, get something like get the value corresponding to the smallest key, right? Or get the value corresponding to the largest key, and things like that. Okay. So a collection is just a group of objects. So that's what the collection interface is basically trying to describe. Every object in the collection is called an element. And so the collection interface is the interface that defines the most general operations that a user can ask a collection to perform. Right, so things like get, contains, and add. So there's the list of all of the collections in the collection interface. Sorry, of all the methods in the collection interface. Notice that collection as that it extends this thing called iterable. So it turns out iterable is another interface. The iterable interface is the interface that provides iterators. So in other words, that interface is where this method comes from. An iterator is an object that knows how to iterate over the elements of a collection. And so it's this interface here that lets you write a for each loop in Java. So when you write a for each loop in Java, what the compiler is actually doing is it's actually using this iterator method to loop over the elements of the collection. What else is there? So methods like size and is empty, contains, add, remove, those are all of your basic operations that collection says any collection object must provide. Right? And that's why list has a method called add, why it has a method called remove, why it has a method called contains, is empty, and size. And that's why set has all of these methods as well. A list is a collection that holds its elements in a numbered sequence, right? So it's a collection, but it does extra stuff, right? So you can get an element by an index, or you can set an element by an index. Right? So list adds those methods. So it gives you methods that give you positional access, or methods that will change elements given an index. Right, so there's a remove by index, there's a set by index, there's an add or insert by index. Search for objects in a list, and the list will tell you where its numerical position is. There's iteration as well, so you can loop over the elements of a list. But because the list is in a particular, the list keeps its elements in a numbered sequence, The list iterators let you do extra things that you can't do with a plain old iterator. And then you can do things like get the sublist from a list. So there's your list interface, right? So the list interface extends the collection interface. So that means that every method in collection is also in list, right? And then list adds a bunch of methods on top of that, right? So there's get, set, and remove, and add by index, right? So these ones all have an index, right? Those methods don't exist in collection, right? Because collection doesn't know any. Collection doesn't say that it does anything by index. Right? The set interface is a collection that can't contain duplicate elements, right? And the set is interesting in that it doesn't add any extra methods to collection, right? All it does is it say that all the set collection does is it says that duplicate elements are not allowed. Right? So your set interface looks exactly like the collection interface in terms of its methods. And then finally, there's the map interface, which is its own separate interface, right? And your basic operations with the map, we've seen those, right? So put and get, they operate using a key, right? You can also remove using a key. And you can ask if the map contains a key or a value. What else is there? So you see, these are interesting. So in a map, you can ask for the set of keys. You can ask for the collection of values. If you want to, you can ask for the keys and their values at the same time. Right. So that returns a set of what are called entries. An entry is just a key value pair. And so that's called the entry set if you want to get both the keys and the values at the same time. So that's it for maps and the collection framework. Eventually, we're going to implement a bunch of different lists ourselves, right? So instead of we're actually going to look and see how array list is implemented and how linked list is implemented. But that's not going to happen until the end of the course. We go back to the map interface for a second. Yeah, we can go to the map interface. Right now. Okay. Do you have a question about the map interface? Keeliju, do you have a question? Sorry, the slide before this one. So not this one. You mean after? You mean this one? Oh, this. Map doesn't. Yeah. So map doesn't extend collection. It's its own interface. Right. A map can't. So the reason map doesn't. So let's go back to the collection interface. Right. So a collection interface. So this is what every collection has to provide. These are the methods every collection has to provide. Right. So you can add an element to a collection, right? But that doesn't make sense for a map, right? Because to add something to a map, you need to specify both the key and the value, right? Whereas this add method, it just specifies, in this case, the value, right? So you can't use the collection interface to define a map, right? To define the methods that a map must provide. Because methods like add, well, add in particular doesn't make sense, right? Contains and remove, you could do those for a map, but they would be inefficient. Right? For maps, it's much more efficient to ask if it contains a key, and to remove, it's much more efficient to ask it to remove a key, right? Rather than to remove an element or a value. Right. So that's why the map interface is its own interface, right? Because the methods that a map has to provide are different than the methods that a plain old collection needs to provide. Okay. So that wraps up part 1 of the course, more or less. So if you're reading the notebooks soon, so I guess within a week or so, you should be reaching part 2 of the notebooks, which is not this one, which is objects or classes. All right, so at this point in the course, we're now going to start to create our own types. Right? So this is the part where we actually start creating classes and making objects using our own classes, right? Rather than just relying on the classes provided by the Java standard library. So before we start talking about classes and how you make them, we need to make sure that you understand a bunch of fundamental terms. Okay, so we've seen types before, right? So a type is just a set of values and the operations that you can perform with those values, right? Int is a type, right? What's the set of values for an int? Well, it's just all the integer values between min value and max value, right? What can you do with an int? Well, I can do arithmetic with an int, right? So int is an example of a type, right? String is an example of a type, right? What are its set of values? Well, the set of strings are the set of strings are made up of any sequence of 0 or more characters, right? It doesn't matter if you know that they're Unicode, right? You just need to know that strings are sequences of characters. What can you do with strings? Well, you can join them together, right? Using the plus operator. You can ask if two strings are equal. You can ask for a character in a string, right? And many, many more. Right? So strings are also types. Lists are also types, right? So list is an interface, right? But we've already seen that the list interface actually defines a bunch of methods, right? So you know what the operations that you can perform are, right? Those are all the methods defined in the list interface, right? What are the set of values? So in other words, so what set of values can a list be, right? So a list is any sequence of 0 or more elements of the same type. So those are all examples of types. Right? You know what the primitive types are. I don't have to talk about this again. And you know what the reference types are, right? So anything that's not a primitive type is also a reference type, and that includes arrays, which is a bit odd to many programmers new to Java, right? So an array is considered a reference type in Java, even if it's an array of primitive values. Okay. So how do you get reference types in Java? So the answer is you need a class or an interface. So all classes or interfaces are reference types, right? And so what are reference types? Well, they're just user-defined types. So things like array list, right? Those are examples of classes, right? Now remember, array list says that it implements the interface Java util.list, right? Now that interface, right? So interfaces are not classes, right? So Java util list is not a class, right? But it is still a reference type. Now what's an object? So an object is just an instance of a class, right? Which is, so the analogy with int is that 5 is an instance of an int. Number 5 is just an instance, right? Number 1 is an instance of an int. The number 2.5 is an instance of a double. Right? So an object is just an instance of a class. And the way you make objects is, so in other words, to make an object, you need a class. To make an int, well, you need to to make an int, you need to know that the Java language provides a primitive type called int. To make a string object, you need to know that there's a class called string. And it's the class, so it's the class that's used as a blueprint to make objects. Right? So one way to think about an object is whenever you make an object, you take your class and you clone it. So that's a sort of not a great way to think about it, but it's one way to think about it, right? So what's in a class? What's in an object? Well, everything that's in this class is in an object. At least everything that's not static. So for example, if I want to if I create a new array list, and that new makes a new object, right? So I now it calls the constructor, the array list constructor, to fill in the contents of the object. Right? And so this ends up creating an array list object using the class array list. Right? So in other words, the object on this, the object that's created here is just an instance of an array list. So whenever you see instance, you can think object, or alternatively, whenever you see object, you can just think instance. Right? Whichever way is more clear to you. Now, in Java, there's no way for a programmer to use an object directly. So in other words, variables don't store objects, right? And there's no way for you to get to an object directly. There's no way for you to get to an object directly. Instead, you get to an object using a reference, right? And a reference is just an identifier that can be used to find a particular object. In other words, a reference lets you find a reference uniquely points to some object. So, a reference points to an object. Right. So, how do you find an object, or how do you find a particular object? So one way is if you happen to know the address of the object in memory. So if you know where that object is sitting in memory, then you can use that as a reference. And that turns out to be the way that many Java implementations work. References are just memory addresses. But that's the language doesn't say that's the way it has to work. But it turns out that's the way it works in many implementations. So T, in this example, is a reference to the object that's created on this side of the equal sign. Right? So in other words, T is not an array list object. Right? So T doesn't store the array list object. Right? T stores the address of the array list object that's created on the right-hand side. So one way to visualize the difference between primitive types and objects is with this thing called a memory diagram. So a memory diagram, this is just a very, very crude, visualization of memory. Right? This isn't the actual way that it works. Right? This is a very gross simplification of how memory works on your computer. So you can think of, imagine that your memory is just a giant array. Right? So the memory on your computer is just an array, and you can get to every individual chunk of memory using an address, right, or an index, right? So this thing on the right-hand side, that's my array of memory, right? The addresses here, those are just indexes, right? So if I want this box, that has the address 98 or the index 98, right? If I want this box, that has the address 99, right? If I want that box, that has the address 700. The addresses are unique, right? So no two boxes have the same address, right? Because we're imagining this to be an array. Furthermore, you can only store one thing in each box. So I'm only allowed to put one value in a box. Okay. Over here, there's a third column. That's the variable name. So if you make a variable, a name will appear in this column over here. All right. Suppose I have these two lines of code. Right. So double x equals -1, and then list t is a new array list. So when you make a variable, its name appears somewhere in this table, right? And it's beside some address, right? It doesn't matter where you put it. Okay, so for our purposes, it doesn't matter, right? In real life, it actually matters, right? So the way your computer actually works, certain types of variables are placed in certain areas of memory. So here's my variable x, right? Is the x, and the address x is found at the address 100. The value that's stored in memory is actually -1 here. Right? So if you have a primitive type, and the thing sitting in memory is just the value of that variable. Primitive type variables actually store a value. Right? If x was an int, there would be an int here. Right? If x was a boolean, there would be a boolean over here. Right? True or false. And if x was a car, there would be some car value here. Right? And there's only one. So you can't store a bunch of different values in the same box at the same time. Now, for the array list, so t refers to an array list object. So here's my variable t. It's sitting at address 101. What's stored in memory? It's not an array list. Okay. Instead, it's the address of an array list. Okay. So that A indicates that this number here is actually an address. Right? I need something to indicate that this is an address, because if I just write 700, that might be the int 700. I'm just going to use an A after the address to indicate that it's actually an address. So if you go to the box at address 700, which is here, that's where you find your array list object. Sitting here, well, who knows, right? In fact, there's not something just sitting here. There's probably a bunch of stuff down here as well. So inside that array list object, there's probably an array. That array is sitting here and here and here and here and so on. So it's occupying more memory below it. I don't actually know what's there right now, so we're not showing it in our picture, right? But there's a bunch of stuff that's associated with the object after address 700. At least in our picture, at least in our memory diagram picture, right? How it actually works in real life is another story, but that's good enough for our purposes. Right? So references store addresses, primitive types store values or actual primitive values. So keep that in mind as well. Right? There is a notebook that uses strings to talk about. They use strings to show you how to draw more complicated memory diagrams. But this is important, right? When you're using objects, you are so when I use T to access an object, right? The object isn't sitting here in memory. I have to jump somewhere else in memory to get to the actual object. Right? So looking ahead, you can imagine I make another variable u, right, whose address is also 700A. Right? So I guess I can u 700A, and I can do that in the following way. Right. So in Java, if you now write u gets the value t, right? So this is actually pretty important, right? So when I make this variable u, right, on the right-hand side, I don't make a new array list. Right? T, I made a new array list, but with u, I'm not. Right? So there's not a second array list object in memory. Instead, what this means is that u and t both refer to the same array list. In other words, so T points to that array list object, and U also points to that array list object. So we say that T and U are both aliases for the same object, right? Alias just means a different name for something, right? So T is the name of this array, is a reference to that object, and U is also a reference to that object, right? If I use T to add an element to this list, right? Then U also sees. So if you use the variable U, you also see this a list where the element has been added to the list. So these are both saying that they refer to the same list. Okay. So keep that in mind because that's going to be important as later on. The object model. Quarter after, 16 after. Do I want to talk about this? I guess we'll start this. I'm not going to get through it though. So the object model. So the programming that you did in CISC 101 and CISC 121 was something called procedural programming. So in procedural programming, what you basically you take normally what you do is you take a program and you try to break it up into functions, and then you pass information to the functions, right? To and from functions, right? So you pass in arguments to the functions. That's just information, right? Those are the inputs to the functions, and then the functions might return something back, right? And so that's the return values from the functions. And then somewhere, either in a main function somewhere or using global variables, that's where you keep all the information for your program, right? Object-oriented programming is a little bit different. So instead of decomposing a program into separate functions, you decompose your programs into separate components called objects. Now in Python, you did this, but you didn't realize that you were doing it, right? So when you were using a list or a dictionary in Python, those are actually objects. So you were actually doing some object-oriented programming already, although you may not have known that you were doing that. So you break your program up into individual components, and the components contain their own data. So you can make, for example, you can make a point object that knows that has the coordinates of a point, right? You can make a date object that stores the time and date of some the time and date, right? You can make a string object that stores a sequence of characters. Right? And those objects are able to operate on the data that they own. So for example, you have a date object, you can tell the date object to change the date to some other date and time. Right? And so internally it changes the information so that it reflects a new date and time. Now, in object-oriented programming, there's four main elements in this thing called the object model. There's something called abstraction, there's something called encapsulation, there's something called modularity. Hierarchy, we actually saw a little bit with that UML diagram, but we're going to talk, that's the main focus of part 3 of the course. Right. Okay, so I think I'm going to stop there because we're almost at 20 after the hour, and we will talk about the four main elements of the object model in the next lecture. Vincent had a question about the assignment. Is there a specific way for us to create the methods you want us? You mean, is there a specific way to implement the methods? Oh, yes, that's what you're asking. You are asking, is there a specific way to implement the methods? No, I don't care how you implement the methods as long as they do what their contracts say they do, right? So every method has a big documentation comment in front of it. So as long as you satisfy the description of each method, it's fine, no matter how you do it. So I suggested one way would be to use a map, but the map is actually the harder way to do it, I think. There's an easier way to implement the isYellow method. Okay, any other questions about the lecture or the assignment? Can I talk to you? Sure. Anybody else? All right. I'll stop the recording there and end the lecture there.